Okay,
Hi,
Bogdan, it's yours.
thank you. Hi. So today I will shortly describe the current state of our planning of maintenance revisions of aircraft for CESA Techniques. So, kind of the overall goal is to try to schedule automatically the tasks in a maintenance revision. I'm not going to go too much into the detail of what is maintenance revision of aircraft, but essentially it is something to maintain the airworthiness of aircraft. So that means to make sure that the aircraft has less probability that it will fail during operation. So there must be maintenance planned in advance, or if something happens to the aircraft, it needs to be repaired. But typically, maintenance includes many checks of components and then maybe replacement or fixing of some components. So to maintain the airworthiness of the aircraft, there is many uh, tasks that one maintenance revision could include, maybe up to maybe in the range of hundreds. And the goal is to try to schedule all those tasks automatically in. And then there are different ideas that we explored, but here we will discuss how we use session log data. So this is data on how mechanics work on these tasks, and this data is provided by us to us by CESA Techniques, and we try to analyze it and create maintenance plans based on that, and then try to validate somehow the results of the resulting plans. So in the beginning, we have some input from CESA Techniques. So this is somehow how they currently do the planning of the maintenance revision. In this view, this is in Excel, and they have some sort of categorizing the tasks into several categories. So we see here the category of which part of the aircraft the maintenance would be performed, and then there is also what category of task is done. It's test, inspection, some opening, closing, and things like that. Unfortunately, we don't have any data regarding these uh, plans because these are high-level plans, but we have session data. This means start and end times and who performs from what group of mechanics on what part of the aircraft, what task, and so on. We have this data for specific tasks, and these tasks are in these individual arrows, as you can see here. So this is the session log data. I will just quickly name a few important fields. So we have the start and end date of each session. We have the group of mechanics, that the code for the group of mechanics that performs. So there is avionics, external, internal mechanics, and so on, wash. There are several, I think around 10 or 15 groups that mechanics are categorized in. And then the other things, we have the code for the task, we have some description of the task, and we have to which revision it belongs. Also, it could be called a package or work package. We also have the model of the aircraft, its age during the maintenance, this particular maintenance checkup. And you also have when the work package is scheduled to end, to start end to end. I think this is sufficient. So here is a little bit of a more just to view how the work package or the revision is performed by the mechanics. So on the x-axis we have the start time, sorry, we have the time. So these, let's say, lines are how the mechanics work on a particular task. The tasks are on the rows. So it's just to kind of see how the overall work is performed. So this is the model that is relevant for the planning. So as we said, we have the work package of the revision, which is the set of the tasks that needs to be performed, which is for a specific aircraft. We have the work log or the session log where we have the start and the end. We have it's associated with a specific task type, which could have some additional information with it, and it is associated with the mechanic and to which group the mechanic belongs. There is a little bit more about the task types. They come from maintenance manuals, and there is quite a lot of information about them in those manuals, but we have a very short description of the tasks, which is structured. It's not like in PDF. So we have the type, the task type associated with the aircraft. We have also steps, which we don't use for planning, but there is maybe potential future work here. And we have the task ID, how the task is identified, the task type. We have some description. And then this is a problem of opening CSV file in Excel. This is supposed to be the ATA code, which is a standardized code for the component that, or the system part of the aircraft that is being maintained. Then we have some description. We have to which group this, which mechanic group can perform this task. There should be also total time. I'm not sure if this is the right field, but there is a time which is an estimate how long this task type should take. And the header column is a general category for the task type. So this is essentially this header in the task type description corresponds to these arrows in the general plan. This is kind of the data that we have. And we did different analyses. Unfortunately, the analysis was not systematic, so we kind of experimented with different things. So here is the distribution of the start times of all the tasks. So we can see that a lot of tasks start in the beginning of the work package. So on the x-axis, we have the start time of, we have the time of the work package, relative time from 0 to 1. So this is the start of the work package, and this is the end of the work package. And on the epsilon, we have how many tasks start at which part. So we can see that there is a lot of tasks that start in the beginning. There is also some tasks that start later on. The graph on the right is the same, but is for work sessions in individual tasks. So most sessions typically start in the beginning of the task card, and there is not that much sessions afterwards. Okay, so another statistic that we looked at, this is a more advanced statistic. So here we see the work package again from 0 to 1,000. This is the in kind of relative numbers from the start to the end of the work package, and we see for a specific task card here, for a specific task, we see when all of its sessions were performed. So this is for one work package. This is for another one, and so on. Each row is for a different work package, and this is just a snippet we have for this task, maybe 20 work packages, but I couldn't show them all of them. If you're interested, I can switch to a different view to see them. And so you can see how these tasks start in different work packages differently. So this inspired the next statistic, which we are looking into kind of the merge of all of these rows into one diagram, one chart. So here we see again from 0 to 1,000. This is the relative time in the work package, all the work packages, and this is for a specific task, and we see its individual work sessions and how long it takes. This is in minutes. And finally, this is a graph that is similar to the previous one, with this exception that we have on the we only show not the sessions, but we show the central relative time in which the most job was done, and we plot all of the work done on the task execution in each of these work packages. So all of these are individual work packages, and the execution of a particular task in these work packages, and how long it took to execute this task. And the black line here represents the average among all of those. So we can say that this task card is on average executed somewhere after the first fifth of the work package, but you can see how much it varies where the execution occurs. Yeah, so this is kind of a statistic that we did not yet use for planning. For planning, we just use the start time as indicator of when the task starts, and we don't consider maybe work sessions that start here and then end here for the same task. I don't have an example for this here, but there are certain tasks that have such executions. And final thing regarding planning is, regarding the analysis, is we try to see how much these revision work packages have similar tasks. So this is several work packages. Each line is a work package, and we see the task cards are on the x-axis. They're ordered alphabetically, let's say, and we can see that there are streaks where we have similarity. So you can see here, for example, this line is kind of similar to this line, which means that these two work packages have similar tasks. And a more general view of this is to kind of compute the similarity of the work package revisions and to plot it. So this is all the work package versus the work packages and their similarity. The more blue the dot, the more it is the work packages are similar, and the more white they are, the more they are not similar. So this is for, if I'm not mistaken, for all work packages, and therefore we have for different aircrafts, they will have different tasks, so they will not overlap. So this is kind of the analysis, and I will continue with the scheduling. I will start with some ideas that we have in the beginning, and also that some of which were actually performed. So the first one is to try to schedule the tasks according to their average start time. So we take all the tasks from the work package, and we calculate the average start time for each of these tasks from history, and that's the schedule. The average start time is obviously calculated with relative times, and then it is scaled to the actual start and end, scheduled start and end for the planned work package. However, based on our analysis of how things are ordered and how things can change when they are executed, it seems that this is not a good idea. And also, our colleagues from Chesa Techniques found out that this is really not suitable. So we wanted to try something different. So we also tried extracting the order of work package of tasks in work packages from all revisions. And in this case, we extracted some rules that some work packages, I'm sorry, some tasks are always ordered in the same way in all work packages. However, we just found in the order of tens, so around 50 tasks or pairs of tasks that are ordered like this, while each aircraft could have thousands of tasks. This is a very small sample, and we could not use this strategy to take all of the work packages and try to find the order that and reuse that. So this was the first attempt, and I'm not going to discuss that. And the third attempt was to take the history again, but not try to extract the order of tasks from all of the work packages, but only from certain, let's say, interesting work packages and or similar work packages. And that's what I will describe in a moment. The last thing, which is potentially a future work, is to try to use this standard planning problem with scheduling, which we schedule resources. So to schedule the tasks according to some resources. So, for example, we have a certain amount of mechanics. So how to create the plan according to this amount of mechanics. Or we also have another information from the description of the tasks, and that is that the aircraft sometimes needs to be it has to be provided with electrical power, or sometimes it does not have to be provided with electrical power, depending on the task. And so we can also try to use this resource of electrical power, whether it is on or off, to schedule the tasks so that we reduce the amount of times that this state changes, for example. But we didn't implement that yet. So it's a potentially future work. Okay, so sorry, this is some wrong slide. So how do we schedule the tasks according to the similar revisions? So the algorithm has several steps. We start with finding the similar work packages. So how do we find the similar work packages? Well, we take the set of tasks that are defined for the work package that we want to schedule, and we want to find the set of tasks from other work packages that is as similar as possible. So it's based on set similarity, and here is the formula that we are using that is used in the algorithm. So we take the intersection of both sets, and we divide it by we take the size of this intersection and we divide it by the sum of the sizes of the individual sets. I'm not sure if I think I missed something here. I need to subtract the intersection, because now it would be twice. Sorry, maybe there is a bit of a mistake here. So based on this, I order the work packages and then use that order to traverse the similar work packages and trying to extract a partial order of tasks. Sorry, I just need to have a sip of water. So starting from the most similar work package, we start to extract the order, and here is the result when we extract the order from several work packages. So we start, the result is some network or graph, which we add always one arrow at a time when we traverse the tasks in the similar work package in the order that they were executed in the past. There is different ways how to construct this graph. Currently, what was implemented is that we don't add an edge if there is also if both nodes that we want to add an edge to already have an edge. So we can, if there is another node here, we can add this node to the existing graph. So we can add an edge between existing node and node that is not yet attached to the graph. But we cannot create an edge between these two nodes already in the graph. This could be relaxed, this condition or this restriction, to make more, to reuse more of the order in the work packages. And that could be done by, for example, not restricting adding edges to the existing graph, but restrict adding only those edges that do not create a cycle. So it's a bit more relaxed. We will have more edges, and which will allow us to schedule it more according to these reused work packages. After we take this partial order graph, we construct it. After this, we have to schedule the tasks according to it. And so how it is done, I don't include too much details because there is not too much time. We start with the root node, so we take this one and we schedule it in the beginning of the work package. So the work package has some start time that it needs to execute, and we schedule these tasks in the beginning, and then each subsequent task, this means the tasks that follow the root task, the root tasks are going to be scheduled after the end of this task. And the duration of each task is the duration of the average execution of the task. So this is kind of how we schedule this. There is also some details about reusing the times between the tasks from reused schedules, but it's not that important. So there is an attempt of automated evaluation. So this is my last input. So here we have two measures of the resulting schedules. And on the left, we have a measure that we compare each pair of tasks, if they are ordered the same way in the original execution of the work package. And it seems that so we this is the measure, and using this measure, I created a random schedule, 100 random schedules, and compared these random schedules and the similarity to the original schedule with the planned schedule. So you can see here is the standard, the amount, how many times our schedule is compare, how many standard deviations it has from the random schedule. So we can see here that in the small amount of tasks, so this is the X is the amount of tasks in the work package. So for a small amount of tasks under 100, we have errors in the schedule which are comparable with a random plan, which is something that we cannot use. But the more tasks we have, it turns out that it's better, and we have we are a lot better than not a lot better, but better than, definitely better. It's not mistaken with a random schedule. And so this is for the one measure, and this is another measure which is not comparing only the whether two pairs are ordered the same or opposite, but this compares how away from each other they are. I can show you very quickly in numbers so that it is a little bit better. So here is the two measures that we have for our plan versus reality, what was actually how the plan was performed. And then we have here how much this is away from the random plans. So it is completely far away for the biggest plans. So we have over 800 tasks. And the more we go down, the difference from the plan grows. And yeah, so this is kind of the idea to compare that. We have also one.
Yeah, we're still seeing the graphs.
Sorry,
We are
You are not sharing anything else.
aha, sorry. How about now?
No, through the presentation. I think that if you start when you started to share, you just started to share on the presentation.
Yes, I understand. Entire screen. I see. Sorry about this. Okay, sorry. So these are the columns for the two measures which describe how much our plan is different from the original plan. So this is from 0 to 1. And so this is the difference. The smaller it is, it means the closer we are to the plan. And this is how much we compare this difference to the difference of random plans. So this is the amount of standard deviations from the random plans, from the mean value of the random plan. So we are very far away from the random plans, from the mean of the random plans for certain bigger work packages. So there is something to this planning method, but we need to investigate because we cannot. We need to investigate more because we are not sure how much of which part of the plan is good and which part of the plan is not good. So we can say that what is the overall quality of the plan, but we cannot say which parts of the plan are good and which are not. So this is something that could be looked into in the future. So sorry for taking a bit longer than it should have been. And that's it. Thank you for listening. Do you have any questions?
Thank you both very much for the presentation. Are there any questions?
Yeah, I do have some questions. I was not sure about the evaluation exactly. Could you explain it better what it means, those dots? So what is the number on y-axis?
Yes, again, it's kind of tricky to explain. So there is
Why is it negative, the number?
yes, I will explain. So here I have statistics for random plan for this work package. So
Yep.
what are the statistics for 100 random plans compared to the original plan? So it's the average. Sorry, the statistics are here. I made a mistake. So this is the minimum. We have the minimum difference from the original plan. We have the maximum difference from the original plan, and this is the average
For random plans, yeah.
for 100 random plans. Yes. And this is the standard deviation of this sample. So we have 100 random plans with minimum, maximum, and average. And from the average, the standard deviation is this number. So now I'm trying to look into how much each random plan is similar to the difference of my plan. So the difference of the random plan is how much is similar to the difference of this plan. And it turns out that here it is very different. It's very far away from the random plan. Because the deviation is so small. The difference from the average is minus 18. So I am way below the average when it comes to the difference.
So what does it mean? That it is less precise than the random plan, or
It is better. So the more negative this number, the better.
okay.
And this is what is shown on these graphs. Is that the bigger the plan, the more accurate it is, its sequence generated by the algorithm than when it is smaller. When it is smaller, we have some plans that are comparable with the random plan and some that or even a little bit better, but then also some that are worse than the average random plan. And there is one interesting plan here around 300 tasks when we have around 300 tasks, and we still get a worse result than a random plan, than the average random plan. So there are certain things that need to be investigated.
Okay, and okay, thanks. That's now clear. And how to how many work packages in percentage relatively it can be applied? If you say, for example, that from number 400 you consider the planning is quite good enough, so how many for how many plans it would apply, like in percentage, like 20% of plans are over 400 tasks, or I don't know. Do you know this number?
No, I don't know, but we can maybe say bigger than 300. Sorry, 100, let's say. And we can check how many of those are here. We have 317 that are over 100. And we have, I think, 7 1,400 work packages. But a lot of them are under 100, under 100. So this would be better for bigger packages than for the smaller ones.
Okay, yeah, maybe you feel like 100 is good number. I feel like 400 is good number to check against, right? Okay, but
Sure, yeah, we can
we
check.
we can have a look at it later. The last question I have is how is it related to domain knowledge? You didn't say any any insight if you use the domain knowledge here or not. So I'm not sure how much domain knowledge is
Oh.
implemented in creation of plans. That's first question. And another in, is it now disabled here, or it's domain knowledge is not used at all?
So
I mean domain knowledge like that aircraft needs to be under electricity or something like that.
No, we don't use much domain knowledge except the distinction between the scopes or the groups of the mechanics. So I didn't specify this here, but if I go back to creation of the partially ordered tasks, here we do that per mechanic group. So we do that only per mechanic group. So another thing that could be done is to do that for all of the tasks, not for the tasks for specific group, because now we have separate schedules that are not connected. And this might cause wrong scheduling between for tasks between groups which have something in common between groups.
Okay, thanks. That's all. Thank you.
Thank you.
Could you explain to me what the random plan is? I might have missed the explanation. Is it just a randomly generated plan? What good would that be? Or is it a randomly selected plan that was created manually?
Yes, it is a randomly generated plan. So I take the start and the end of the work package, and I just randomly assign times to the tasks.
And how useful is such a plan? Is it realistic at all? Like if you randomly generate a plan of I don't know how many tasks, is it even like how well does it represent a realistic plan?
Well, it definitely has some issues. I didn't generate the plan to have, for example, the distribution of how much time is between tasks or how long the tasks take. I was just specifying the start time, which is used for the planning. So it's not very realistic plan, but for the measures, it's realistic in this sense that I'm looking into these first two measures. I have added more measures. So for that I would have to change the random plan. But for these two measures, it's enough because I am just looking into the order of the tasks and comparing that, not the exact times.
Yeah, but if the plan is completely random, so it could be a complete nonsense with respect to how the company operates. Then why would you compare your solution to this? I would expect the generated plans to be compared to what the company actually used, so that you would be able to show that your plans are better.
Yes, unfortunately we don't have plans. We don't have data for plans from CESA Technics. What we have is the actual performance of the plan. So we have the session logs, and I compared my plan with the plans that we generate to the session log, and this is the difference. But I wanted to make sure that what I generated and the measure that I used actually means something. And that's why I use the random plan to see how much what I generate makes sense.
Okay, I don't understand how a random plan helps in that. I mean, the first measure, that's what I would expect. Like compare it to existing data and see, yeah, our plans are better. But a completely random plan, I don't understand how that helps you. Like if you generate a completely random plan, it could be a very good plan, and in that case, the
Yes.
difference you would want the difference to be as small as possible, or it could be a complete nonsense, and then you would want the difference to be as big as possible. And how do you tell which one it is?
Okay, yeah. It was an attempt to make some statistical how significant statistically this plan is. So the random plans is not one; there are 100. So if I randomly generate a good plan, I could not randomly generate many good plans or always a good plan. So it statistically speaking, the random plan should be bad. So if our plans perform the same as a random plan, then we can just use a random plan algorithm and just forget about all that and or not do anything at all because it doesn't matter. But because we have some difference from the random plan, we can say that, well, we do something better than a random plan. That's kind of the idea. I'm not sure if I explained this. This is supposed to be some statistical analysis, and maybe someone who does statistics better should be able to do this the right way.
Okay, it makes sense to me in that if you have a bunch of friend or a lot of random plans, and then you get some statistical distribution, and you can compare it to that. If this is based on some theory, I'm absolutely okay with it. I'm just now that you say that you have a bunch of plans and you take some distribution of these and then you compare it to that, it's okay.
Mhm.
But if you claim that you expect statistically that the most of the generated plans are bad, then my question is, why do you expect that?
It's I think that I'm not, but I'm not basing anything on this.
Okay.
I'm just saying that the random plan is well, it's a random plan. It doesn't have any information about the problem. It just generated randomly. And when I have a sample of, let's say, 100, I can say, well, all of these plans, I know nothing about them. And for me, they're just nonsense. So I want to compare my plan to the nonsense and see if how much better it is or if it's
Um,
the same. That's the main idea.
okay, I'm not a professional in statistics or in the domain. I'm just not sure if even if the plan is completely random, maybe the nature of the work uh, doesn't require tasks that follow each other, so they could be
Yes.
done randomly. So
Yes.
I'm still not sure whether the claim that a random plan is statistically expected to be bad is something that I would buy. That's just my only.
Oh yeah. Okay. Okay. So there is a lot of questions about this. First of all, this analysis does not. Um, so this all of these numbers is comparing to the actual execution of the plan, not to what is the correct thing, because maybe the plan itself is not good. So that's one thing. Second thing, as you said, we don't know if tasks should be ordered in a certain way or they can be just ordered irrelevant of each other. So, but comparing to the original execution of the plan, definitely most of the random plans would be wrong, because there is just one order, and it is quite possible, there's quite a big possibility that the randomly selected start time of the task would be before or after the actual original task execution. So that's why I say it is most likely it will be wrong.
Okay, yeah, I'm so sorry for dragging this so long. So maybe one question is, could you like evaluate the plans with some measure? Like I would expect that better plans would take less time. The tasks would be ordered so that they can be done in parallel, so that the total time of work on the aircraft would be as short as possible, and then compare these measures, like the plan that was actually done, like the work, and then the plan that you would generate, and say, okay, our plan is better because it would take, I don't know, 50 hours less. That
Yes.
would be for me. That would be the best like comparison. Not the difference, because the difference could be good or bad, but like this kind of objective comparison.
Yes. So we don't have this kind of evaluation yet. Also, it is kind of hard to say that shorter plans are better, because what is better is based on our discussion with CESA Techniques, is that the deadline is not too far away from the actual end of work, because when the deadline is before the end of work, then the operator company is not happy, because they have to reschedule their flights, because they start scheduling after the maintenance, right, to kind of make sure that they can use the aircraft and make money out of it. But if the deadline is after, then they just have too much time, and the aircraft could stay there, and they would have to keep it somewhere, and will have to take care of it. So it's important the deadline to be correctly scheduled, and then it should be that the tasks will have to fit in the deadline. One second thing that we were discussing is that each task, right, these tasks could be checks and tests of components or systems in the aircraft, which may lead to finding that something is wrong with some component and needs repair or replacement, which actually creates a new task in the plan, which is not in the original set of tasks, which is, for example, to replace some system. And this could happen in the beginning of the work package, but sometimes also at the end, near the deadline, which is not good, because then that will extend the deadline if this new task takes too long and overshoots the deadline. So one of the things that we spoke about is if we can schedule tasks for which we know from history that have are associated with new tasks that are added to the plan that could cause the plan to exceed the deadline. So yeah, there is something like that, but we don't have that implemented yet to verify it.
Okay, I'm sorry. One more clarification. So
Sure.
so the point of the project is not to make more efficient plans that can be done faster or with fewer resources. It's to do a better estimate of how long the work will take. From what you are now saying, that's what I understand. Is
Yes.
that correct?
So yeah, to kind of create a schedule so that they don't have to schedule all the tasks themselves manually, so that there is already something that is historically proven to be okay. And also to have some basic like qualities that it doesn't exceed the deadline and things like that. Very basic, not some reduction of resources and things like that. This is planned for the future, maybe if we have projects with them to plan the resources on the workshop in the between different maintenance between different aircrafts and things like that. So we don't have this as a main goal for the planning.
Okay, thanks very much. Now I understand it much better.
Okay.
Okay, perfect. Thank you all for the discussion. I believe that right now it's clearer to everyone. So thank you, Bogdan, and I'm stopping live stream.